Good day, everyone. My name is Loreto Atamosa, and welcome to the last lesson of our course for microeconomics. This will be a two-part video discussion, and we will focus on the understanding of production and cost. Our intended learning outcomes for this video discussion are the following. First is to explain the production and cost theories, and second is to compute and graph the different cost curves. Ready? Let's start! So in this section, the most vital concept relevant to the study of production theory and estimation and to show in the learning objectives will be operationally defined to create a common frame of reference to how these concepts contribute to your future managerial career. And so let's try to discuss these important concepts one by one. First, we have production. So production refers to any economic activity that combines the four production factors, example, land, labor, capital, and entrepreneurship, form an output that will give direct satisfaction to customers. It includes material goods or the provision of any services that satisfy the wants of people. So production is the process of converting inputs into outputs. Therefore, the action of making or manufacturing from components or raw materials or the process of being is so manufactured. Now, second, we have inputs. Inputs are commodities and services that are used to produce goods and services. Inputs are generally classified into three broad categories, including land, labor, and capital. So in economics, factors of production, resources, or inputs are what is used in the production processes to produce output, that is, finished goods and services. Now, when we say outputs are the various useful goods and services that results from the production process and either consumed or employed in further production. So goods and services that are ultimately consumed are called final goods, while those that are used to produce other goods are referred to as intermediate goods. Therefore, output refers to the total production of goods and services of a whole country or even a given period, its gross domestic product. So the term may refer to all of the work, energy, or goods or services produced by an individual, company, factory, or machine. Now let's move forward to technology, labor-intensive or capital-intensive. So when we say technology, it is the body of knowledge applied to how goods are. So in other words, technology is the production process employed by firms in creating goods and services. So technology can be classified into two. We have labor-intensive technology, which means utilizes more labor resources than capital resources. So labor-intensive technology is usually employed by economies where labor resources are abundant and cheap, while capital-intensive technology utilizes more capital resources than labor resources in the production process. So capital-intensive technology is employed by industrialized economies since capital resources in these economies are cheaper than labor. So what's the difference between the two? So a business that is capital-intensive implies one in which higher capital investment is required. So the business owner needs to invest more in the acquisition of sophisticated and automated machines, including diverse equipment. So there might be a need to hire only a fewer number of workers whose primary duty would be to operate the machines. But in labor-intensive production techniques, the focus is to hire more employees or humans to handle the production process. Furthermore, in capital-intensive methods, higher investment is required to maintain the machines used for production, and output could be considerably higher in the long term. But in labor-intensive technologies, businesses can only increase production by asking workers to work extra hours or employ more temporarily staff for a specified period. And so the decision as to what type of technology to employ depends upon the availability of the resource and its cost. Thus, if more labor is available in most cases, industries or economies will be more labor intensive since the cost of labor will be cheaper than the use of capital. So in other hand, if capital is more abundant while labor is scarce, then industries or economies will be more capital intensive since capital will be cheaper to acquire. So capital intensive and labor intensive production techniques are two popular techniques used in the production of goods. Firms, irrespective of their sizes, can also decide the system that is ideal for them. Nevertheless, we are going to be as plain as possible in this comparison. So the aim, as always, is to provide valuable information. Now, there are two important concepts that are essential in our discussion of the production theory. So they need to be explained and clarified first. So when we try to distinguish the short run and long run, we should remember that economists do not partition production decisions based on any specific number of days, months, or years. Instead, the distinction depends on the ability to vary the quantity of inputs or economic resources used in the production of a good or service, such as raw materials, labor, machinery, equipment, and etc. So the long run is a period of time in which all factors of production and cost are variable. So in long run, firms are able to adjust all costs, whereas in the short run, firms are only able to influence prices through adjustments made to production levels. Accordingly, production inputs are classified into two main types, which are fixed inputs and variable inputs. So a fixed input is any resource, the quantity of which cannot readily be changed when market conditions indicate that the change in output is desirable. So examples of fixed inputs include the plant and buildings that the firm uses as well as the machinery and equipment. So a variable input, on the other hand, is any economic resource, the quantity of which can be easily changed in reaction to changes in output level. So for example, if the demand for t-shirts increases because of the Christmas season, we cannot readily buy additional new sewing machine or build a new factory. So in this case, our fixed inputs are the sewing machines and factory. And since the manager can simply hire additional workers and change the amount of materials used in production, our variable input is the additional sewers hired and or the added raw materials required for the production of additional t-shirts. So now we can link the concept of fixed and variable inputs to the short run and long run concept. So when we say short run, it is the period of time so short that there is at least one fixed input. Therefore, changes in the output level must be accomplished exclusively by changes in the use of variable inputs. Conversely, the long run is a period of time so long that all inputs are considered variable. So the long run is therefore known as the planning horizon. So this is because in the long run, the firm can already build new plants or purchase new machinery instead of just hiring additional labor or increasing the purchase of raw materials. Now let's move on to the production function. So a production function is the functional relationship between quantities of inputs used in production and outputs to be produced. In other words, the production function specifies the maximum output that can be produced with a given quantity of inputs given the existing technology of a firm. Now there are three important production concepts. These are total products, marginal product, and an average product. We have a video presentation from Khan Academy to better understand this topic. Here, let's watch this.
In previous videos, we introduced the idea of a production function that takes in a bunch of inputs. Let's call this input 1, input 2, input 3, and that based on how much of these various inputs you have, your production function can give you your output. In this video, we're going to constrain all of the inputs but one to really take it down to how does our output vary as a function of one input. And as we do that, we're going to be able to understand these ideas of total product, marginal product, and average product. So to give you a tangible example, let's say that we are running an ice cream factory and we care about how much our ice cream production per day varies as a function of the number of people working in the factory. So let me write this down. So per day, ice cream production. And so let me make a table here. So in our first column, I am going to put our labor, which is, you could view as the input that we're going to see. How does that drive output? So I will put labor. So you could view this as workers per day. Workers. And we're going to see how our output varies whether we have 0 workers, 1 worker per day, 2 workers per day, or 3 workers per day. Now our next column would just be our output. And we'll say that's our total product as a function of labor. TP standing for total product. And let's say that we know if we have 0 people working in our ice cream factory, well, then we're going to produce 0 gallons of ice cream. And let's just assume that our output is in gallons, and it's gallons per day. If we have 1 worker at our factory, well, then we're going to be able to produce 10 gallons a day. If we have 2 workers at our factory, we're going to produce 18 gallons a day. And if we have 3 workers at our factory, let's say we can produce 24 gallons a day. Fair enough. Now I'm going to introduce an idea, and you have seen this word marginal perhaps at other times in your life. I'm going to introduce marginal product of labor. And the way to think about marginal, that's how much for every increment of one thing, how much more of the other thing do you get? So here, our marginal product of labor says for each incremental unit of labor, for each incremental person working there per day, how many more gallons of ice cream am I producing? So my marginal product of labor, when I go from 0 to 1 workers, I'm able to produce 10 more gallons from that first worker. Now what about when I go from 1 worker to 2 workers? Well, then I go from 10 to 18 gallons. So that second person gets me an incremental 8 gallons per day. And then as I go from 2 people working there to 3 people working there, well, my total product goes up by 6. So my marginal product of labor for that third worker is going to be 6. Now, there's something interesting that you're immediately seeing here, and this is actually pretty typical, is that your marginal product of labor will oftentimes go down the more and more people that you add. And you might say, why is that the case? Well, they're just not going to be quite as productive. That second person might be waiting while the first person is using the mixer, and that third person is going to be waiting while the first person and the second person, maybe they're using the restroom or something, and the third person has to go. And you can imagine you had 4, 5, 6. At some point, you're not even going to be able to fit people into the factory. And so you're going to have what's known as a diminishing marginal return. And you see that right over here. As you're adding more and more labor, your marginal return is getting smaller and smaller. So this is a diminishing marginal return. Now the last concept I'm going to introduce you to in this video is that of average product. And this is average product as a function of labor. So AP for average product. And all that is our total product divided by our labor. So over here, when we have 1 worker, our total product is 10 gallons, and we're going to divide that by 1 worker. So our average product per worker is going to be 10 gallons. Now when we have 2 people working per day and we're producing 18 gallons per day, our average product as a function of labor is going to be 18 divided by 2, which is going to be 9 gallons per worker per day on average. And then in this last situation, it's going to be 24 divided by 3, which is 8 gallons per worker per day on average. And you can see this visually as well. I can draw this on a curve. Let me do that. So if on our horizontal axis, I have our labor units, which is workers per day. So 1, 2, and 3. So this is labor right over here. And our vertical axis, I'll have our total output. So total product, I could say. So let's say that's 10, 20, and let's say that is 30 right over there. Well, this first one right over here, when we have one person working in the factory, we produce 10 gallons per day. And this is total product right over here. When we have two people working in our factory, we produce 18 gallons a day. So it's going to be just like that. And notice, the slope has gone down a little bit. We have a certain slope here, but it's a little less steep there. And that steepness of that line or of that curve, that tells you about the marginal product. So it's a little bit less steep, so our marginal product of labor has gone down a little bit. We're having diminishing marginal returns. And then last but not least, when we have 3 people working, we're able to produce 24. So 3 and 24 might be right over there. And once again, we can see our diminishing returns. It gets even a little bit flatter. We go from 0 to 1. We added plus 10. And you can see that there in the marginal product of labor. And then as we add one more person, it goes plus 8. And then we add another person, it goes plus 6. So in general, if you see total product as a function of labor, or total output as a function of labor, and the curve is getting less and less and less steep, well, that tells you that your marginal product is going lower and lower, and you're getting diminishing marginal returns.
Great, isn't it? Therefore, total product refers to the total output produced after utilizing the fixed and variable inputs in the production process. So total product is designated in physical units like vans of rice, number of rubber shoes, number of t-shirts, and etc. While marginal product of an input is the extra output produced by one additional unit of that input, while other inputs are held constant. For instance, assume that we are holding land, machinery, and all other inputs constant in the production of t-shirts, while the average product is equal to the total product divided by total units of input used. And for the graphical representation of these concepts, another video presentation is prepared to us by Economics Fund to better understand these ideas. Here, let's watch this.
In this tutorial, I'm going to discuss production theory, and this is the first video of a 3-part playlist. In this tutorial, I don't use any numbers or calculus. I just introduce you to the ideas of total product, marginal product, and average product, and their relationships. It turns out quantity produced is equal to some function of labor and capital. And in your textbooks, you'll see Q is equal to function, that little f means function, of L, and capital is denoted by K. So quantity is a function of labor and capital. And sometimes, since capital is fixed, that's what that little line over the top means, it's fixed, it's written as quantity is equal to a function of labor. Along the x-axis, I'm going to graph units of labor, and that can be number of workers or hours. Along the y-axis, or the vertical axis, I have units of output or quantity. As labor is added, I produce a quantity. L1 is my labor, and Q1 is the quantity. If I add more labor, I produce more. Now L2 is my labor, and Q2 is my quantity. But if I keep adding labor, a point comes in time where I'll actually produce less. So I have L3 and Q3. And you'll learn why that is in this video and the subsequent 2 videos. And this is the total product curve. The brown line is a total product curve. Again, holding capital fixed or constant. Now if I take that same unit of labor line, horizontal line, and I pull it down like that, that's units of labor. And on the y-axis, I have units of output per worker. Now I can plot average product. Now, average product is the amount of labor, in this case L1, divided into the amount of quantity, is average product. In other words, quantity divided by labor is equal to average product. Your professor and your textbooks probably use the notation APL to represent average product of labor. I'll just use average product. Now if I pull labor straight down, then average product is Q1 divided by L1 at that point in time. Marginal product's a little different. Let me draw that curve in. The blue line is marginal product of labor. Let me add labor and quantity at point 1, and also labor and quantity at point 2, L2 and Q2. If I add some labor, how much does quantity go up or change? By the way, that little triangle, that little delta, means change in. So marginal product is the change in quantity divided by the change in labor, which is equal to Q2 minus Q1 divided by L2 minus L1. This is all equal to marginal product. Also, it may be written in your textbooks as MPL, which means marginal product of labor. So it looks something like this. You may recognize this as, hopefully, maybe you recognize it as the rise, and this is the run. So we have rise over run. Which is equal to the slope. So marginal product is equal to the slope of the total product curve at any particular point. In this case, we let the change in labor be very small. In fact, the change in labor is 1 labor unit. So in essence, we want to know is, if labor goes up 1 unit, how much does quantity produced change? It's a slope of the total product curve. Marginal product of labor is a slope of the total product curve. A tangent line at any point on that total product curve is the slope, or the rate of change, and that's also marginal productivity of labor at every point. And some points are more interesting than others. For example, this is where marginal productivity of labor is 0. And then it goes negative. If I draw a tangent line and just touch the total product curve like that, and I draw a straight line down, what that shows me is, at that point, average product is equal to marginal product. Another point of interest is when that tangent line is flat, and that means the rate of change is 0, or the slope is 0. So it crosses the horizontal axis right at the 0 point there. That value there is 0. And anything beyond this point, the slope is negative. So now I have 3 distinct regions, or stages. I have stage 1, which is the first part there, stage 2, and stage 3. Stage 1 is increasing average product. Where marginal product is greater than average product. Stage 2 is decreasing average product, but I still have a positive marginal product. Stage 3 is a decreasing total product and a negative marginal product. And with negative marginal product, total product is actually falling. Adding more labor causes total product to fall. One last idea is diminishing marginal returns, and that's from that point forward where marginal product of labor, the slope is actually negative or decreasing. Again, total product is actually, I should say, quantity is a function of labor and capital, where I have fixed capital, and so it is quantity is a function of labor. Often in your textbooks, you'll see this labeled as TP, or total product, TPL actually. You'll see AP representing average product, APL, and MPL representing marginal product of labor. Up next, I'm going to do the same thing, but I'll use numbers. And I'll talk about total product, average product, and marginal product of labor, and I'll use numbers.
Ready? Amazing, right? And that's the end for the first part of our video discussion. See you in part 2 for our Module 3 Lesson 7 video discussion. Stay safe and healthy. Goodbye!